Hello everyone. This video we are going to talk about two frames, right? Because I'm going to show you some of the animation, right? So that's why I'm going to switch to the slideshow. Hopefully that will work okay with this Zoom meeting recording, right? So uh, a new term, right? Two frame. So we just learned the term of the coordinates, right? Now I'm introducing a new term, frame. You may wonder what's the difference, right? And in Fanuc robot, in my opinion, they didn't give the strict definition between these two, right? So I'll just put my personal opinion over here to help you to understand what's the difference between these two. Uh, Fanuc robot has the default jogging coordinate system. So the one we learned before, joined and world, they are default. So that means whenever you have a Fanuc robot, they already have these two coordinate system built in. So you can use that to jog a robot anytime you want, right? And but in fact, the join is more fundamental with the robot, and world is something built on top of that, right? So it's just from my work experience, right? Some of the robot when I work with that, they have the battery to hold up the values of the encoder because they all controlled by the controller. They need to memorize the positions. But if the battery has some problem, or if you forgot to change the battery every year, then those recording will be lost. So once you lost those recordings, you won't be even able to jog a robot in world because all the zero, remember we talk about world 000, right? If robot doesn't know where it's 000, how can they jog in world, right? So that's not available once you have a problem with the backup battery. But you always have the join because the six axis can always be joined, be moved around. Then you can define the zero. On top of that, you can have the world coordinate back. That process is called calibration, right? But that's not the focus of this video. So I just want you to understand what I mean by the default jogging coordinate system. So that's the term we use, coordinates. And frame, strictly speaking, the definition of this frame is the set of three planes, right? Planes, that means XY plane, XZ plane, and YZ plane, right? Every two dimensions, you can have a planes, right? So those three planes, if they are in 90 degree to each other, it is called a frame or Cartesian coordinate system, right? So that's a long term on that, right? Cartesian coordinate system. So by looking at this definition, the joint coordinate we learned before is not a frame, right? Remember when we talk about join, we mean that from J1 to J6, each different join rotate in different angle, right? Circular angle degree. So that's the join coordinate, but it's not a frame. So that's the difference now, right? But the world we use, right? XYZ, WPR, it is a frame because they have three planes at right angle to each other that meet the definition of frame, right? So from here you can see join and world are default coordinate system. And when you are jogging the robot, right? Most time people will use the word coordinate. But when you introduce the frame, then they're different. Joint is not a frame, but world is. All right, so that's the difference. Hopefully you can understand so far, right, what we learned. And on top of that, look at the third one. the robot user, so we are the robot user, we can set up extra frames. So on top of world, right? World is default, but we can have customized frame, right? So they are called two frame, user frame, jog frame, right? In other different videos, I will talk about that, right? So this one will particularly talk about two frame. So this is first thing, right? As a user, we can set up actual frames. And after that, we can also jog, manually jog the robot in our defined frame, just like join and world. Again, they are default. They are provided by the system. But once we have the customized defined frame, we can also jog the robot into the frame we just defined. Right? So hopefully by this slide, you can have a better understanding of these two concepts, right? That's the coordinate and frame. Then let's look at what exactly is two frame, right? Very easy to understand from this picture. So when you have a robot from the manufacturer, right? Especially on this one is a Fanuc robot, yellow robot. You don't have tooling to attach on it because they don't know what you're gonna do with the robot, right? So that's why they have a default. This is second time I use the term default. Default, that means the system will give you the original setup. So they set up the two frame starting point as the center of the J6, the end of J6, the end of robot arm. So that be the default, right? That's the best they can do because they don't know what you're gonna attach, what kind of tooling on the robot. Right? Then it's your job, right? Then you have a gripper. You decide you want to use this robot to grab parts. And then when you install the gripper on top of your robot, there are some extra things you need to do. Because once you attach, that you can see this picture, once you attach the tooling successfully with the robot arm, then over here, this is where the work is supposed to be done, right? The center point of your finger, the robot finger, is where you try to grab the part. And that's where the real job being performed. And you want to move the default into this real position on here. So as you can see here, offset. So if you want to have a very strict, very plain, easy understanding of two frame, it is a offset. So you want to change from the default location into the real position. So you can see here in the manual, they remind you, you must set the two frame to define the point on the tool at which the work is being to be done. So that's basically what I just explained, right? So you may ask, why? Right? If I don't do it, what's gonna happen, right? So let's look at a animation here. So even though we haven't talked about the program yet, all right, but over here, let's look at this Teach Benton program. So over here, roughly you can figure out, right? We have two positions, P1, P2, and that's on the robot job, right? So you want to start from P1, then go to position 2. And L, that means linear. So you want to move a straight line between 1 and 2 as a line, right? So if you don't have the TCP uh, correctly set up, right? So then you will have a trouble because as I said, robot always have the default. This is the default, right? So the manufacturer set up as a default. So robot will know that's my TCP, right? If you want me to move from P1 to P2 with straight line, I'll just maintain my default TCP as a straight line, right? Because I don't know what real tooling is about. But your real tooling, you see here, is like a sort of that I don't know, maybe glue gun or something like that, right? You can see here, that's where the job being done here. That's the real TCP. But if you don't do the setup, then robot will never know your real TCP is here on the red dot. It will just keep the default TCP at the straight line. So once you run the program, you will see something like that, right? Something like this, straight line maintained on the default, but on the real job, it's not a straight line, it's a curve. Hopefully this animation will run. Let's see here. Yeah, it's run, right? You can see here, the green line is a string, is a straight line, right? Straight line. And but the red line is curve. So that's the problem you will run into if you don't teach the TCP. All right. But next, I'm going to show you if we teach the TCP and the two center point successfully being transferred, being offset from the default into here, then this job will be done in straight line. So that is what we want to do at the end of the teach. All right. So over here, you can see, run it. Yeah, so now you can see the straight line between P1 and P2, right? Again, if you don't do that, you will see the problem. But once you move the TCP to the real location, this is what you're supposed to see. All right, let's look at the next. So the next slide relates to the section 1 on the two-frame lab. How do we test the two-frame? All right, so the well-taught TCP will maintain stationary. So over here, so if this is a like a spot welding, a welding gun, all right. So if you point the tip of your welding torch to a fixed point, and then if you jog the robot in world, and remember we talked about the second right-hand rule, right? If you rotate around XYZ, the TCP should remain stationary. So that means you can see here, when you jog to this location, that tip is there. When you jog to this location on the robot, the tip stay there because robot knows that's my two center point. I don't want to move away from there. I just need to rotate around it, right? So this is what uh, I need to tell you first. All right, so no, this is the slide, but now I'm going to show you the on the uh, handling pro. All right, so let's see the first part. So oh, sorry, over here. So this is the lab I'm talking about, right? The section 1, how to select and test frame. All right, so this is the part I can do a demo on here. So again, on the file I gave to you, I record some of the positions. So I can let you to quickly move to there. So I'm going to move to PR4, cylinder pointer, shift move to. So you can see robot quickly move to the top of that cylinder. So once its robot is there, I'll zoom in to let you look at it. So, so you can see the yellow dot roughly is the center point on the top surface of this cylinder, right? So if I jog my robot in world, right now it's in joint, I'm going to change to world. 10% speed is okay. So I'm going to use the right hand rule to jog, second right hand rule to jog the XYZ rotation. Watch what happens because this TCP is being taught, right? So, and that's supposed to maintain stationary. You can see here, robot rotate, right? Just like what we talked about before, rotate, but TCP stays there, right? That's negative, that's positive. And then if I rotate around Y, same thing. Right? It's just rotate around. The TCP stays there. And rotate around Z, you can see here, rotate. It stay there because robot knows that's the center. It doesn't move away. All right. So this is a, a TCP being set up. Right. Now I'm going to switch to different tool. Right. And with the simulation, we can use what we call the jog menu. Shift chord. You're going to bring this up. So once you bring this up, right now the tool is on number 1. All right. So Fanuc robot has 10 different frames. So we can match each frame to a different separate tooling. All right, so over here, if you press dot, will be the last one, number 10. So I'm going to press dot on my keyboard. You will see that tooling gone, right? So you can see here, that's what I mean. The robot without any tooling, right? So that's from the manufacturer, right? So this is the original robot, right? Without any tooling. And of course, you can attach different type of tooling on top. I set up different ones. All right, let's look at them. All right. So number 1, you already see that. That's the pointer, right? You can see here, that's the pointer. And let me switch to number 2. You will see I have a gripper on top, right? Maybe I should uh, move my robot up a little bit. You don't want to crash that, even though it's a simulation. So you can see it's a gripper. So you can use gripper to grab the object. So then you can, let's look at number 3. On number 3, I had a hook on the end of the robot, right? You can use the hook to take some of the object on the machine or something like that, right? Applications depends on what you want to do. And let's look at, this is number 3 now. Let's look at number 4, what I have. I don't even remember it. All right, number 4 is different. So if you look at this, if I zoom in a different angle, it's a painting, painting gun. It has 2 different nozzles, right? So you can see that's a default TCP. The real TCP will be different from, right? Again, uh, the default is here. But when you paint, right, it's not even on the nozzle. It's supposed to be somewhere the painting evenly distributed on the surface, right? Depends on the application, maybe 10 millimeter away from your nozzle. I don't know, that depends on the manufacturing uh, recommendations, all right? But that's my point. So that's default, right? Then that's the painting job being done. You're supposed to set up this to here. So that's the user's job. That's what we're gonna learn uh, with with the this tool frame, right? So let's look at uh, other tools. All right, so I like to show you more. 4 and 5. Let's look at 5. 5 is a MIG welding, right? Welding torch, right? So if I zoom in, you can see they have the wire stick out, right? That's the real job to be done, right? So your TCP is supposed to move from here to the tip of the wire, right? So that's where uh, the job are going to do, right? So uh, let's go back to the number 2. That's what I'm going to require in the lab. So if you have a gripper, right? So for example, you complete installation on the gripper, and then you want to test if the two frame will work or not, right? So I have another position called cylinder gripper, right? Shift move to that will bring the robot quickly to the location here. So same as before. Remember that with pointer, right, it's on the top surface, right? So over here, same thing. My gripper right now is on the top surface. The center is roughly also on the center of the top surface, right? Remember how did I test? right? I jog world and rotation, 100% speed too fast, maybe slow down a little bit. Then I'm going to jog around X and Y, see what happened, right? You can see here, it's different now, right? It moves away because robot doesn't know the TCP is here. It still think on top, right? If you don't let robot know, robot will still think that's my TCP, not on here, right? So that's why when you rotate on the world coordinate, let me show you again, reset, right? So for example, if you stop here, when you rotate around Y, same thing, that move away. It didn't stay, right? So that's why that tells you this two frame number 2, even though you have the gripper installed on there, it's not being set up, right? And next video, I'm going to talk about how do we set up on the gripper on the tooling. All right, I see you on the next video.